Hi, I wanted to create a video for my Math 043 intermediate students about how to identify functions. So we are asked in our class to decide if a relation is a function or not. So first of all, what's a relation? So a relation is just some kind of relationship between x and y. So it says here a relation is a set of ordered pairs. So our ordered pair is x comma y. But what gets tricky is there is a variety of ways to state that relationship. So I've shown some here. So first we might just have a table, a t-table of x and y values. So when x is 2, y is -3. When x is 0, y is 5. We're all familiar with that. Since we use the word set here, the next one I have some set notation. I have some curly brackets, and I have several points that are part of that set. This third one on the right, some people may not be as familiar with. This is what we call a map. And it's just a different way of stating the relationship. It can be quite useful when it comes to determining if something's a function. So on the left, we have x values, and then they are mapped over to a corresponding y value. So in this set, it just so happens that when x is 3, y is -2. And for some reason, I don't know if I have an error in my typeset here, but they actually state that point again. And then they show that -2 also points to -2. So if you don't like the map, you could take the map and rewrite it as points. Okay, but what if we don't just have what I would call a finite set? So those first three examples, those are all finite. They each have 3 or 4 points, and that's it. A map, a graph, I mean to say, where we have the graph of some kind of equation. We don't know what the equation is, but all of these points represent ordered pairs as well. Or since this is an algebra class, we might just have an equation, right? The relationship between x and y is often just given as an equation. So those are all just examples of relations. As I said, the tricky part is, what way am I going to give it to you? Now we're really interested in functions. So functions are a quintessential part of mathematics, especially higher mathematics. I don't know why they don't introduce these concepts earlier. It would make my job a little bit easier. But a function is a relation, and it's a very specific type of relation. So read the definition here carefully. Each x value is paired with one y value. We often talk about functions as having inputs and outputs. So for each x I input, there will only be one y that is output for that x. Some more vocabulary. The x value is called the independent variable because typically we're picking an x value to plug in, and then the y value is dependent. It depends on what value of x we're interested in. Okay, so it doesn't seem like there's much to the definition of function, but I want you to think a little bit like a lawyer and really read that carefully. Each x value is paired with one y value. So let's determine if these relations are functions. Okay, first example, just have a set. There's only 4 points here. So we see when x is 2, y has a corresponding value of 3. When x is 4, there's a corresponding y value of 8. When x is -1, corresponding y value of 6. X is 0, y is -2. Okay, this one is a function. For each x, there is a corresponding y value. I think it would actually be a little more helpful to see a situation where we don't have a function. So the second one, I have one of these crazy maps. And again, it may be helpful if I rewrite these as just points. So when x is -4, y is 1. When x is -4, y is 2. When x is -3, y is 2. My arrows are a little hard to read. I think that 9 is supposed to be pointing to that 3. I think this one goes with this one. Okay, I already kind of gave it away, though. This is not a function. Let's take a second to reread that definition and think about why this one is not a function. So for each x I input, do I get out one y value? Okay, so which one do you think is the issue here? Which set of points? So it's actually here. When x is -4, y is 1, but when x is -4, y is also 2. That's a fail. That's a no. We can't have that. Now we can have two different x values give us the same y value. That's okay. But I can't have one x value with two different y values. That's not allowed. That's just how we define a function. So that one's a no. So what about number 3 down there? So I know my table's a little funny because it's a sideways XY table. Again, if it helps you, you might write out these values as points, x and y. So is it a function or is it not a function? Let's see. This one, got a 50-50 chance, right? This one is a function. One way I can tell is I have 4 different x values, so it's going to pass because there's no repeat on the x. Back here on number 2, that's where these maps are actually helpful. If I were to draw a map of this, I want to see only one arrow coming out of each x value. If you have 2 values coming out of an x value, then it's a no. This one's a yes. Now, I know some students are thinking, but you have some repeating values in the table. What about these ones? That's okay. Your y values can repeat, your x values cannot. So an example I often give in class is, let's say it's the end of the semester and you go to look up your grade. So you log in to the class and you go to look up your grade. And for your login, there should be one corresponding final grade, right? So you log in and you see that you got an A. Now that doesn't mean that your friend can't log in who is in the same class. It doesn't prevent them from getting an A. You could both get A's. So 2 different inputs gave us the same output. But what cannot happen is you can't log into the course and find out that you got both an A and a D. That would be a malfunction. That would not be a function. You would be concerned if that happened. Now, there are special functions called one-to-one functions, where there is one y for one x, but a general function, y can repeat, x cannot repeat. Okay, so in the first case there, those were all things that we just had a limited number of points to look at. It's easy to see. What if I have something more complicated? What if I have an equation? An equation has infinite points that make it true. So how am I going to know if each x value only corresponds to one y value? It's actually a really tough question. One way to help us figure it out is to rewrite our equation as y equals some function of x. So I'm going to solve for y. So in my first example, 4x plus 2y equals 12. We're actually quite used to doing that in this case, I hope, because this is kind of like going from standard form to slope-intercept form, so we do that a lot. Okay, I don't have a lot of room, so I'm just going to divide by 2. I'm going to assume that you all follow me here. I get y equals -2x plus 6. Okay, so now that I have y in terms of x, I want to think about for each x value I plug in, would I only get out one corresponding y value? That is the question. Now that's a very abstract question. Like I said, there's infinite values to plug in. So let's just try some easy values and think about it. So good values to try: 0, 1, -1. Always easy to try, right? Okay, so if I plug in 1, -2 times 1 is -2 plus 6. When x is 1, y is 4. And I actually don't really care what answer I got for y. What I care about is, did I only get one answer? I just got one number there, right? So that's looking pretty good. Let's try some more just to be sure. If I plug in 0, that's pretty easy. I get the intercept there. I get -6. If I plug in -2, I get 2 plus 6 is 8. Now again, I don't really care about what the answer is. I care that for each x I put in, I got one and only one number. So in general, if I plug in a number for x, I multiply it by -2, and then I add the 6, am I only going to get one answer? Yeah, I should only get one answer. So this one is a function. Okay, now that is a linear function, and in general, most lines are functions. There's one special exception that I'm going to talk about down below. Okay, what if I have something that's not linear, like x squared minus y equals 0? And you may or may have not talked about those kind of equations in your algebra class. Okay, but I'm just going to add the y over, solve for y. So y equals x squared. So again, the question is, each time I stick in an x value, do I only get out one y value? So again, let's just try 1, 0, -1, but you could try any values you like there. Let's see. When I plug in 1, 1 squared is 1. I take 1, I square it, I get 1. That's one answer. I plug in 0, I get 0 squared is 0. I plug in -1, -1 squared is 1. I plug in 2, I get 4. Whatever values you want to plug in. The real question is, am I only getting one answer for each one of these? Okay, that's a yes again. For each distinct x that I put in, I got out one value for y. I can have repeating y values, that's okay. But for each x I put in, I just got one answer. All right, again, I think it's going to help to see some that maybe don't work. So how is number 3 different than number 2? They both involve a square value. Okay, but on number 3, y squared equals x. Now, if you know how to solve that for y, that's fine. Or if you think you know how to solve it for y, that's fine. I'm just going to go straight to the table here. This time I wrote -1, 0, 1. That's fine, I hope. Actually, -1. What squared equals -1? Well, again, you may have not talked about that in your class yet. So maybe I jumped the gun there. I was going to say not a real number. Sorry, I don't know how to use my eraser here. Let me see if I can get it. There you go. So not real, if you know what that means. Okay, what about when x is 0? Well, the only thing that's square that's 0 is 0, right? What squared equals 1? 1. Okay, but here's where we run into an issue. There's another value when squared that equals 1. Do you realize that? When 1 is squared, it equals 1. True statement. What else squared gives us 1? Think back to the last example. Sorry, I wrote that backwards. -1. So this one is not going to be a function. So if I solve this algebraically, and we'll talk about this in my class in a later section, I would square root to get rid of the square. Here's the thing though, when you square root, you have to say plus and minus. There's 2 roots, so that's what I was trying to say here. Sorry, I was stumbling a little bit over that. X is 1 has 2 solutions, plus and minus 1. Or if you don't like that, what about if x is 4? 2 squared is 4 and -2 squared is 4. So that's a no. I'm going to go down to number 5. That actually has the plus and minus. That's going to be a no. That's 2 values for one input. If x is 1, I get plus and minus 3. That's a no. That's a fail. Number 4 is slightly different than that. Number 4 does not have the plus or minus, and I know we'll talk in my class about how this radicand is assumed to be positive only. Well, if I'm only getting the positive roots, then I'm only getting one answer. Number 6, you may have not encountered a rational expression yet, but even with this rational expression, I can test out some values. We already have y in terms of x, so that's at least good news. So for instance, I can plug in 1, 3 times 1, minus 5 divided by 2. Now, if you're bad at fractions, you're going to have to get over it. but I really care, did I get one answer? That's a yes. Now, usually I plug in 0, but why can I not plug in 0 here? 0 would make my bottom undefined. Now, that doesn't mean that this isn't a function. It just means we're not allowed to plug in 0, and that's another discussion. We're going to talk about domain. But we can try some other values. For instance, if I plug in 3, 9 minus 5 over 6. Again, I don't really care what the answer is. Do I get one number here? Yes. So this one's a function. It just has some limits on its domain, which I'm going to define in my next video here. Okay, what if I didn't have an equation? What if I have a graph? These are actually really easy to figure out if it's a function. We can use my favorite, the vertical line test. So think about what a vertical line is. Vertical line, first of all, which way is vertical? Vertical's this way, up and down, vertical, like a vertical stripe. And a vertical line has equations like x equal 1, right? It has all the x values are the same, and so we get a vertical line. So the vertical line test says if every vertical line from negative infinity to infinity, all these different values of x, if it only intersects a relation once for every line, then it's a function. So for instance, here's a terrible line. So here's a line, try to make, terrible. It's really hard to do on the computer. So I make a line. Make a line in your notes. The question is, does this line cross the graph only once? And do all lines cross the graph only once? So this one, as terrible as my drawing is, this one passes, yes. And actually what I usually do is I don't draw a line, I just take my finger and scan it and determine yes or no. Okay, what about the second graph here? We don't know what the heck equation this would be, but this is a big old fail, right? I can see right away this vertical line is going to have multiple crosses. That's a no. Okay, this graph kind of lost its axes under this ellipse here, but this one, that's a no. What's happening with this ellipse shape? We're getting plus minus solutions. That's a no. Okay, number 4. Now this one, maybe the graph ends, maybe nothing's going on over here to the left of it, but on the right where the graph is existing, that's a yes. And as I mentioned, most lines are a yes. Most lines, there's one exception. Call this 5B. What line would be an exception to the vertical line test? A vertical line. If I have, again, that line x equal 1, everything's fine until I get to the line itself. And so what are the points on this line? There are things like 1, 2, 1, 0, 1 gabillion, right? So I have one x value for lots of different y values. Vertical lines fail the vertical line test. All right, so those are my examples for is this relation a function and how that can be given in a variety of ways.